In this video, we're going to learn how to convert from rectangular coordinates to polar coordinates. Let's use the following figure to help us establish the formulas that we will use. In this figure, we're envisioning laying a polar plane on top of an xy Cartesian plane. The pole and the origin coincide, as well as the polar axis and the positive x-axis. We have a point P plotted in quadrant 1 in the xy plane, but P could lie anywhere, and these relationships we are going to discuss are still valid. Now, the point P is addressed by the ordered pair x, y in the xy plane, as well as the polar coordinates r, theta. The point P lies on the terminal side of angle theta and is a distance of r from the origin and thus from the pole. We can draw a right triangle where the hypotenuse is the terminal side of angle theta containing the point P, and r is the length of the hypotenuse, since this is the distance from the pole to the point P. Furthermore, the horizontal leg of the right triangle is the distance indicated by x to the point x, y, and the vertical leg of the triangle is the distance y of the ordered pair x, y. Now let's write down some relationships we can observe from this figure. Based on the definitions of the trigonometric ratios, we can write that sine of theta equals y divided by r, cosine of theta equals x divided by r, and tangent of theta equals y divided by x. Also, using the Pythagorean theorem, we can write that x squared plus y squared equals r squared. Now, for this video, we're learning how to convert from rectangular coordinates to polar coordinates. Therefore, we'll have the values of x and y, and we're looking to find the corresponding values of r and theta. So in this case, we're going to use the last two equations that we wrote, tangent of theta equals y divided by x, and the Pythagorean theorem, x squared plus y squared equals r squared. Now, there are some unique situations that will occur when converting from rectangular coordinates to polar coordinates. So let's consider a few different examples to explore each of these situations, then we will summarize our observations at the end. In this example, we will be converting from rectangular coordinates to polar coordinates where the point lies on a coordinate axis. Now this problem states, find the polar coordinates of a point whose rectangular coordinates are -2, 0. Now what we want to do first, let's say step 1, is we want to plot the point in the xy plane for this ordered pair of -2, 0. So the point is going to lie on the negative x-axis. Step 2, let's find the distance r from the origin to the point. Now since the point -2, 0 lies on the negative x-axis, then it is a distance of 2 from the origin or from the pole. So we can say that the value of r is 2. Now step 3, let's determine the value of theta. So let's draw a ray passing through the point -2, 0 that has an angle of pi radians from the polar axis. Therefore, we can say that theta equals pi. So one possible representation of this point in polar coordinates is the ordered pair 2, pi. Now, recall that a point in the polar plane can have infinitely many representations. So in other words, the ordered pair is not distinct. Now, we can add or subtract integer multiples of 2 pi to the value of theta and generate other possible representations of this point. So some other ordered pairs could be 2, 3 pi and 2, -pi. Now keep in mind, we could add pi to the value of theta, and then the r value would be negative. In fact, once we add pi to the value of theta, we can then add integer multiples of 2 pi while r remains negative. So two other representations of this polar point could be -2, 0 and -2, 2 pi. Now let's consider an example where we will be converting from rectangular coordinates to polar coordinates where the point lies in a quadrant. And this problem states, find the polar coordinates of a point whose rectangular coordinates are -3, -3. Again, step 1, let's plot the point in the xy plane The point -3, -3 will lie in quadrant 3. In step 2, let's find the distance r from the origin to the point. So first, let's sketch a ray starting at the pole, passing through the point -3, 3. Now, we know that x squared plus y squared equals r squared, and substituting the values of x equals -3 and y equals -3 from our ordered pair, we have the quantity -3 squared plus the quantity -3 squared equals r squared. Solving for r, we get r squared equals 18, or r equals plus or minus 3 square roots of 2. Now, since we're finding the distance from the pole to the point, then we'll take r equals the positive 3 square root of 2. However, keep in mind that for a polar coordinate, r could be negative, but we'll discuss that scenario once we find the value of theta. So for step 3, let's determine the value of theta. Now, to accomplish this, we will use the relationship that tangent of theta equals y divided by x. And solving for theta, we write this as theta equals inverse tangent of a quantity y divided by x. Now recall by definition that inverse tangent is defined for -pi/2 less than theta less than pi over 2. For our values of x equals -3 and y equals -3, we will have theta equals inverse tangent of 1, which equals pi over 4. Now finally, since pi over 4 is in quadrant 1, but our rectangular coordinate lies in quadrant 3, we'll handle this a few different ways. Now we can leave theta as pi over 4 and choose r to be the -3 square root of 2, or we can add pi to theta equals pi over 4 and choose the positive value of r. So let's write both. So two representations of this point in polar coordinates are 3 square root of 2, comma, 5 pi over 4, and -3 square root of 2, comma, pi over 4. Now let's suppose we were being required to have a value of theta that was negative. Then theta equals -3 pi over 4 will place us in quadrant 3, and thus another polar coordinate is 3 square root of 2, comma, -3 pi over 4. Now in summary, the following theorem states, if P is a point with rectangular coordinates x, comma, y, the polar coordinates r, comma, theta of point P are given by r squared equals x squared plus y squared, and tangent theta equals y over x if x is non-zero. And the coordinates are given by r equals y and theta equals pi over 2 if x is equal to 0. Well, let's go ahead and summarize the steps that we followed in the examples. Now, step 1, we plotted the point x, comma, y. Step 2, find the value of r. Now, if x is equal to 0 or y is equal to 0, we could just use the graph to find r. If x is not equal to 0 and y is not equal to 0, then r is equal to square root of the quantity x squared plus y squared. Step 3, find the value of theta. Now, if x equals 0 and y equals 0, use the graph to find theta. Now, running out of room on the slide, let's go to the next page and continue discussing step 3. If x is not equal to 0 and y is not equal to 0, note the quadrant in which the point lies. If theta is in quadrant 1 or 4, then theta equals inverse tangent of the quantity y divided by x. And if theta is in quadrant 2 or 3, then theta equals pi plus inverse tangent of the quantity y over x.